Welcome. So to start off, I'll just brief you on what the assignment's going to be. Yep, the assignment is 30 minutes. I will give, on D12 I said 40 minutes, the last 40 minutes of class. What I'll actually probably do is that, say, an hour and a half into class, on the hour, so I guess that's what, 5 o'clock? At 5 o'clock, I'll open the assignment, and then you just submit it within 40 minutes or so, the regular. Yeah, it's what we did yesterday and today, Ibrahim. Yeah. It's actually not going to be that long. It's going to be a one-page assignment, 1 page, 2 sides, 4 questions. And you should have more than enough time to do it. Maybe I'll let you do it for 40 minutes and leave the drop box open for a little while, but honestly, there's just not going to be that much to it. There's going to be 4 questions. So the first question is 2 parts. It'll ask you, what's this graph? And it's either going to be a tan, cotan, secant, or cosecant. So if you can tell me which graph is which, you've got 4 marks right there. That's 2 questions. Yeah, that's okay, Hamza. I mean, you know that I post all of the lessons online, right? They're on YouTube and they're on D2L. You know that, right? Yeah, okay. Nothing wrong with Khan Academy. It's great. I just wanted you to know that anything you miss, you can also check out the classes, just so you know. So yeah, 4 questions. First question will be name the graphs. There'll be 2 graphs. We just pick one or name them. The second question, you'll have to give me, given the equation, give me amplitude, period, and displacement. Should be really easy. Third and fourth question will be based on the 2 big topics we do today. One of them is you have to graph a sine or cosine curve. And then you'll need to, for the other question, you'll be given the graph and you give me the equation. And you'll find that it's actually not that much, it's not that difficult to do that. It seems like a lot of work, but once you do a few examples, you'll see it's the same thing over and over again. Certainly easier than unit 3. So I think you'll be okay. And then we'll be done the unit. And yeah, Ibrahim, I see you're saying there's no harm in extra time. I agree, for the most part. Unfortunately, students are taking advantage of the extra time and they're checking all each other's answers instead of just focusing on their own work. So it's been a bit stressful for me, for a few reasons. But anyways, I'll give maybe 40 minutes and then leave the Dropbox open for another 5 or so. Okay, so I'm going to briefly go back in time a little bit, and I'm just going to do this question here. I'm going to do question 2B on page 22, because I want to just recap the fundamental pieces of this unit, at least the unit that the stuff I didn't skip. So you should all know I skipped a huge chunk of this, like every page up until page 15 was skipped. So hopefully you didn't worry about that stuff. I'm just going to rewrite this question, amplitude, period, and phase shift is another word for displacement, so I'm just going to write displacement. Amplitude 1/7, period 5 pi over 3, and phase shift 0. So the question is, in each of the following, write the sinusoidal function with the given properties in terms of sine. What that means is take what you've been given and give me the equation. And the key word here is sine. If it said cosine, you would have to write a cosine function. But it says sine, so we have to write a sine function, of course. So let me show you what this looks like. We need to write a function that looks like this. We need to fill in A, B, and C. And there we go. If we know A, B, and C, A, B, and C, we will have the answer to this question. A, B, and C are actually very easy to get, at least in my opinion. Let me just scooch this down so it's easier to work with. A, B, and C come directly from amplitude, period, and displacement. If you have amplitude, to get A, it is amplitude. A is just amplitude. So right away we have it. We could put that in the equation right away. I'm not going to do that yet. I'll write the equation at the end. But if we wanted to, we could. All right, let's go one step further. From the period Does anyone remember what the formula for the period is? I wrote it earlier. It's written earlier in the book. We know that amplitude is the absolute value of A. Period is 2 pi over B. Good job. 2 pi over B. Displacement, also known as phase shift, also known as phase angle, also known as horizontal shift. Anything that describes something that moves the graph sideways is negative C over B. Good job, Ali. Negative C over B. So in this case, period, if we want period, we know that in this case, period was given as 5 pi over 3. So we need to work backwards. Period is 2 pi over B. We also know period is 5 pi over 3. So we just make them equal to each other and solve for B. One nice, I guess I'll say, shortcut that some students like to use. If you know the formula for period, you can simply rearrange it to get the formula for period. And you can take that as your formula for B if you want. It's up to you, or you can just go from first principles. So if this is true, let's see, 6 over 5. Well, I need to get, what am I looking at here? This becomes, B would be 2 pi divided by 5 pi over 3. So that's a bit of an awkward one. I'm going to rearrange it, show you what I did yesterday. 2 pi divided by, sorry, there's a pop-up on my computer here. Divided by 5 pi over 3. The way that I like to do this is split it up as 2 pieces. First term, division sign, fraction, and then change it to a multiply, flip the fraction. So this colored part here, I'm going to change it to a multiply and flip it, and then it should work out really, really easily. It's called multiplying by the reciprocal, and I covered that yesterday. There's a pi here on top and bottom. That'll be 15 over, sorry, that'll be 6 over 5. So 6 over 5 is correct. Ibrahim got that one. That's a little bit extra work than sometimes we have to do for B, but the most complicated thing I can give you involves 2 fractions. So you need to make sure that you know how to do these. There is tons of practice in this notebook. You know, in this course, especially in this unit, there is more than enough practice. And they don't take that long. You know, do every question in the notes if you want. There's even extra practice online. D2L is filled with extra practice if you go looking for it. So there's no excuse really for not being able to do it, or at least not knowing that you're having trouble. If you're having trouble, then you come see me. You know, you can just send me a message. I'll help you out one-on-one. So displacement, we know that, let me just give you a shortcut for displacement. If you want to get it directly, you can say negative B multiplied by the displacement. That's a fast way to get it. If you want to remember it that way, that's up to you, it's fine. It rearranges the formula. Negative C over B, in this case, is equal to displacement, 0. If you rearrange that, that gives that C is 0. So that's a little bit of an easy one. And we have A, B, and C. So let's write our final answer. Final answer. Y is, what's A again? 1 over 7. 1 over 7 sine 6 over 5 x, also known as 6x over 5, plus 0. So this is our final answer for this one. Okay, so Ali, did you catch why you got your answer wrong? I think you missed that the pi's cancel out each other. All right. So, not that much work, really. Just be very careful about simplifying this fraction, okay? That would be my biggest piece of advice. Other than that, should be okay. You'll see a few of those, though, so make sure you know how to handle them. Let me give you another kind of what-if case. What if, instead of the displacement being 0 for this question, what if the displacement was pi over 2? Let's see if we could handle that, okay? So if the displacement was pi over 2, we're trying to look for C. You know that this is true. So negative C over B. B in our case was 6 over 5. equals displacement. Displacement's pi over 2, all right? So I'm just giving you an example of what would happen if the displacement was not 0, just so you can handle it. So this is our displacement. Sorry, that's our B. This is our displacement. How do you deal with this? Ibrahim says -3 over 5 pi. Let's see. C would be, keep the right side where it is, multiply both sides by the fraction on bottom. The easiest way to get rid of a denominator or get rid of something on bottom that you don't want is bring it to the other side as a multiply. So that's what I'm going to do, 6 over 5. Once you do that, hopefully you'll see it becomes a little bit easier. 6 times pi is -6 pi. 2 times 5 is 10, and you can simplify that down to -3 pi over 5. So Ibrahim got it, Ali got it. That's 2 people. Hopefully the rest of you are following along as well. I'm trying to just give you an example of how to handle that sort of fraction stuff. You know, get the practice. It's not going to go away. There's no reason I can't give you a question with a fraction in it, because there are just fractions in Trig. It's just the way it is. I can't really just ignore them. I'd be changing the course if I did. All right? So just take your time. Get good with the fraction stuff. Don't play too much Call of Duty. You'll be fine. Okay. Let's move on. Let's actually do the work that we need to cover today, the new topics, because that's all review. And what we do today will actually be even more review of what we did earlier, because they all are related concepts. That's one nice thing about this unit. It all follows itself. So this is page 23. What we're going to do is we're going to graph sine and cosine. And before I do anything, let me just remind you that sine, the sine graph, the most basic version of it looks like this. And the y-intercept is at 0, 0, okay? That's our most basic sine graph. Our most basic cosine graph looks almost exactly the same, except instead of starting at 0, 0, it starts at 0, 1. That's the only difference. In fact, they are the same function. They've just, the cosine is shifted by pi over 2. I didn't use your name, Hamza. How do you know I'm talking about you? How could you possibly know? So that'll come up more later. I just wanted to mark those down now. The only difference between sine and cosine is one is shifted over a little bit compared to the first one. So let's do this. We're going to graph this function and this function. And by graph it, I mean we're not going to use Desmos. We can use Desmos to check our answer, but you need to be able to graph it by hand. And the book does an okay job of explaining that. Mr. Tom's videos do a good job of explaining this. I'm going to try to do it as quickly and clearly as I can, because it's my opinion that the only real way to get good at this stuff is just see some examples. You know, I don't want to introduce the topic for 12 hours, okay? So that's what I'm going to do. This is, we saw this before. This is just reference. This is just formulas. One thing I will say is it says when attempting to sketch the graph of a trig function, that's over here, when attempting to sketch the graph of a trig function, we will need to locate the position of 5 key points that outline a single cycle. What that means is, for example, in this case, we need this point, this point, this point, this point, and this point. What is special about those points? Well, if I was to very simply draw a little sketch just next to it, because I don't want to muddy up the sketch too much, the 5 points we need for a sine curve are 3 points where it hits 0, a maximum point, and a minimum point. This is a maximum point, it's going to be equal to A. This is a minimum point, it's going to be equal to negative A, or negative amplitude, okay? That's really all we're concerned with here. If this was cosine, it would be basically the same. But the important thing is we need 5 points. Let me go one step further and show you how we're going to think about these points. So what we see here is the most basic sine function that we can get. And what we have when you look at this, like if you try to break it down, let me actually go forward to the table and come back to this. We can make this function here based on this table. And this is kind of like our cheat sheet. If you use this table, you have everything you need. Okay, so I'm going to put a bunch of stars on it because it's the most important part of this whole topic. I'm going to make a note of the table. That'll tell us what our x and y values are, what our coordinates are that we'll make our graph from. And we need this idea. We need to know that if we have our period and divide it by 4, it will give us the distance between each point. So let me rewind, okay? It's talking about displacement, amplitude, periods, minimums, maximums. Let me try to help you understand what this is talking about. When you look at a sine graph, so this is what we're looking at right now, it will have some point here where it needs to start. Of course, that is true. It has to start somewhere. That will be normally our 0, 0 point. But in this case, that's going to be whatever our displacement is. So whatever our value of displacement is, that'll be our x value. But we'll worry about that more in a second. If we go a full period, so for example, this sine has its wonderful day, you know, it does its thing. Eventually, it gets to this point. It gets to its final point. And the name for that, when it goes from start to finish like this, when it completes a full cycle, is the period. That's not new. We covered that before. But in case you're not sure, from the start of a cycle to the end of a cycle, it's called the period. Now, you'll notice that there's, of course, this sine function has been cut up into pieces. Well, what's special about these pieces is here we have our maximum. That's our highest point. Here we have our minimum, or our lowest point, negative a. And in the center, we just have another 0 point. How do we know where each point is? Well, in fact, it's actually very simple. If we know the starting point and we know the period, we just divide the period into 4 pieces, and then we'll add 1, 2, 3, 4 pieces. This whole period divided into 4 will be period over 4, period over 4, period over 4, period over 4. Or in other words, if we have our displacement or our original starting value, we'll add the period to get to the next point. That'll give us our x value. Add another period over 4 to get to the next point, add another period over 4 to get to the next point, and so on. So I guess what I'm trying to say is you have 5 points. First point, add a quarter of the period, you'll get your next point. Add another quarter of the period, you'll get your next point. Add another quarter of the period, you'll get your next, and then you'll get your last point based on that. And the table, which kind of looks like crazy when you first look at it, should hopefully make sense. We start our first x value, 0.1. X value for 0.1 is whatever the displacement is. If the displacement's 5, you put a 5 in that box. And then each time you add whatever the period is divided by 4. So let's see an example. I've talked your ear off already. Let's see how this works. And you can see that I'm not just making stuff up. It's actually not too bad. I'm going to skip this example because it's kind of ugly. I'm actually going to go to a later question. Just ignore what's happening for now. And I'm going to go to practice number 1. I don't mean to skip ahead too far, but on page 29, it's a much nicer example than the original starting examples that Mr. Tom did. So practice 1. Now, it says, sketch the following trig functions. Well, it's only given one function right now. For each, we need to state the amplitude, the period, and the phase shift. Phase shift also known as displacement, so nothing new. Also, the 5 key points should be indicated on the sketch. Okay, the 5 key points are the 0, max, 0, minimum, 0. So let me try to help you understand what's happening. We've been given this function. It's a sine function. We need to look at it, take A, B, and C, use those to give amplitude, period, and displacement, and then use that stuff to fill in the table. So let's just start. Let's start. What's A? A is 0.5. I know it's 0.5 because I'm looking right at it. It's right there. Remember that for a sine function, A, B, and C are given like this. Okay, so B, you take it directly from the formula. What's B? Say it with me. 3. What's C? It's pi over 3. Once again, if you want to know where they come from, it's very straightforward. Okay, I won't color code the whole thing because it gets a little bit messy, but I'll color code it so far. So the amplitude, we can get directly. Amplitude is 0.5. So right away, with just the amplitude, we have a ton of information. And the reason I know this is, and I copied it over here, but this is on the previous few pages, we have a ton of information here. Look, amplitude is here and here. So I can fill in the table. Look, I can put in this box, I can put 0.5. In this box, I'll put negative 0.5, because there is a sneaky negative there. That's our minimum. Of course, it's got to be negative if it's down. And then the other ones are just 0. You kind of get that for free. So for all sine curves, it follows this pattern. You'll have a 0, a 0, and a 0. Here you'll have your maximum. Here you'll have your minimum. In other words, your positive A value and your negative A value. Okay, so maybe I'll make that really clear here. This is a minimum. This is a maximum. You can also call that positive A and negative A. All right, so we have lots of information already. In fact, we already have all the Y values. We just need to find the X values and then we'll start plotting them, just like a normal graph. And again, this is much easier than Unit 3. Just believe me on that. So tell me, what's the period? Let's get the period. Well, 2 pi over B. Period is 2 pi over 3. You got it. As easy as that. 2 pi over 3. So we have period. Unfortunately, if you look at your cheat sheet, period isn't really there. I mean, it is. It's right here, but you have to divide it by 4. So let's divide it by 4 to get the distance between the points. I'll make it really clear here. Let me just rewrite it. So the period divided by 4 is 2 pi over 3. 2 pi over 3 divided by 4. Does anyone know how to handle this? Eight pi over 3. Not 8 pi over 3, although that's a classic mistake. What you need to do, I'll give you a few tricks like this. First of all, I'm going to give you the long method. Write it like this. Your original thing was 2 pi over 3. You're dividing it by 4. Actually, I'll make this an aside because I want the notes to be nice. So let me just carry you over to a little dream sequence over here. If you had 2 pi over 3, we're trying to divide it into 4 pieces. Remember, you can take that and make it multiply by the reciprocal. So 2 pi over 3. Instead, change it to a multiply, 1 over 4. Right? We're flipping this piece. It's the same as multiplying by 1 over 4. Once you have that, multiply the top, multiply the bottom, and yeah, you get pi over 6. That's one way. That's one way. So I'm seeing Hamza, Ibrahim, 2 Ibrahims. You both got that. That's excellent. I'm going to show you a shorter way when you have a system like this. It doesn't always work, but when it does, it makes life faster. We got, what, pi over 6 for the answer? Look at this. When you have fractions like this, just multiply these two and keep that on bottom. So the bottom numbers will multiply together, or the two closest numbers there after the fraction. So what I mean is you have 2 pi, and on bottom, what's those two things multiplied together? It's 12. And now simplify it. And for a lot of students, that makes life much easier. So use whichever method you find easiest. I don't care which method you use, as long as you use your brain and not someone else's. So the answer is pi over 6. Okay, so Hamza, your question, is it pi over 6 or is it 2 pi over 3? Well, it depends on the question. The period is 2 pi over 3. But what we just found here, this here is the distance between the points. That's really what we need. We don't even really need period. I mean, it asks for it, so we filled in the blank. But the period is going to, the period divided by 4 is going to be what we add each time. So every time I get an x value, I'm going to add pi over 6 to it, and it'll fill in this table. Remember, we divided our range into the even pieces. Or in other words, let me just make a little sketch. I'll delete it. You know, normally we have our sign. We take this and this, and we're dividing it evenly into pieces. This is, you know, we add pi over period over 4, add another period over 4, and so on. We're just inching our way up with x values. Okay, so that's not so easy. Some students find that difficult. So we'll do more examples like that. Finally, we need the displacement or the phase shift. Displacement. What is the displacement? Well, it's negative c over b. Do we have c? Yes, we do. It's pi over 3. So negative pi over 3. B is 3. We'll do the same trick. Take the two bottom numbers, 3 and 3. Take 3, multiply it by 3, you get 9. So it's negative pi over 9. That is actually what we needed. We need that number. That will go right in our table as our first value. This might seem like a whole lot of work, and from a certain perspective it is, but it's the exact same steps every time. So you're going to follow this process like you could be a computer and do this. So you're saying c is pi. C is pi over 3, Ibrahim. Not sure where you got the c equals pi. So before I go any further, is there anything I can clarify? Because this tends to make students confused. Anything I can go back through? Displacement is phase shift, yes. There's different words for displacement. Displacement, phase shift, phase angle, horizontal shift, horizontal translation. They all mean the same thing. Okay, so let's zoom out, literally. What do I have? I'm going to make it really obvious here. I'll use some awful color. Displacement, I have displacement. It's this. What do I need to do next? Oops. I need to add my answer for period over 4, which I have, pi over 6. So what is negative pi over 9 plus pi over 6? Here's the cat. Get out of the box. There I am moving. I'm moving villas. So we got keys to the new place today. So things are everywhere. Cats are everywhere. It's a real mess. What's negative pi over 9 plus pi over 6? Well, let's bring up my trusty calculator. Something on my screen, sorry. Let's see, what do we got? If you're not sure how to do this, you know, you don't even need to use the pi. You can say negative 1 over 9. And you're going to add pi over 6, or the same thing as 1 over 6, and put the pi back in after. So 1 over 18. That might seem kind of weird, but that's what it is. Pi over 18. All right. Negative pi over 9 plus pi over 6 gives that. So this plus this gives that. And we're going to do that every time. We'll just add it until we get there. So What's 1 over 18 plus 1 over 6? Once again, I'll take out my trusty calculator. I'm going to just take my answer. I'll just say plus 1 over 6. 2 over 9. So pi over 9. Okay, my ink is a little bit too big. Sorry, it's a bit messy. But if you keep going through this, actually, this is this pi over 9? That doesn't seem right. I'm going to double check my answer. I feel like maybe I did something wrong. Let's see. So can you check your work with me, just so that we're on the same page? If you can't do this, you won't be able to do your assignment anyways. So try to get the practice now. Yeah, maybe 2 pi over 9. That's what I thought. That's what I got last time. Sorry, guys. I'm just, I'm going to throw that kind of out the window. Yeah, 2 pi over 9. I'm not sure how I got what I got, but it didn't seem right. When I graphed it, if I was to graph it, it would have been obvious. Okay, of course, you can do this by common denominators if you want. Like if you had pi over 18 plus pi over 6, you could also say that that's pi over 18 plus 3 pi over 18. That's 4 pi over 18. And you could simplify that to be 2 pi over 9. But that's a whole lot more work, in my opinion, than just getting the calculator to do it for you. So maybe just get the calculator to do it for you, or use the internet. Okay, what's the next one? 7 pi over 18, perfect. That's right. And then the next one is actually 5 pi over 9. So you should be able to get those yourself, all right? I'm going to make it just, I'll make a little note here just so you're clear. How I got 0.2, so when you look back on your notes, it's clear. I took my displacement, negative pi over 9, and I added pi over 6. And that gave me pi over 18. When you're looking back on this, hopefully it's clear where all the numbers are coming from. Do I have everything I need? Well, yeah, I filled in all the blanks. I've got period, amplitude, phase shift. I've got all the points. But remember, these are just coordinates. You know, this is going to be like x and y. We're just going to graph that. So let's graph that. What do we got? I'm trying to get everything in one place. All right, first things first. And before I go any further, hopefully you have this printed. If you don't have it printed, it's okay. But when you make your sketch, you know, especially for the assignment, when you make the graph, make sure you copy the graph paper well. Use a ruler. Try to put in the notches as evenly spaced as you can. Try to copy what I've given you, because otherwise it's just going to be a nightmare. Yeah, there's a question just like this on the assignment. So do your best to make the graph, okay? And again, it seems like a long question. They're not that long. I'm just talking about all the little pieces. So they're not that long. There will be one question just like this on the assignment. It'll be either sine or cosine. Okay, let's get to it. I'm going to write negative pi over 9 and 0. That coordinate's right here. Do you see that? I'm drawing it right here. At pi over 18 and 0.5, that's up here. I know at 2 pi over 9 at 0. 7 pi over 18 is negative 0.5. 5 pi over 9 is 0. Okay, now I have my 5 points. You can connect those points and make a sine curve. Please don't connect them like this. That's not a sine curve. That's a mess. A sine curve is a smooth curve. So you need to take your time and try to make a smooth curve. I'm not very good at this, but I'm going to do my best by making little strokes. Okay. And see what I can get. Okay, so that's about as good as I'm going to get. I can't do much better than that. You know, just be careful. Do your best. You know, you can, there's all sorts, I'll see things like this, and you know, you're just doing your best. You can also use Desmos to graph the original function and try to copy that. No reason why we can't do that. But this is how we do these questions. Honestly, that's the whole topic. I'm going to do 2 more questions like it so that you're sure how to do it. But this is the process. So let me summarize. If you want to know what the steps were, I'll go through the steps one more time for sine curves. You're given an equation. You get A, B, and C. They'll give you amplitude, period, and displacement, respectively, one after the other. Once you get period, you need to divide it by 4 because that tells you how far you need to jump forward. Just 1 second, you here. The period divided by 4 tells you how far you need to add to the displacement. So displacement you should have, because you'll have C and B. Put that in your table over here. Add your period over 4 each time, and then you'll have everything. You know, this part here, the y values are always super easy to get. Just follows the pattern, okay? Ibrahim, your question was, you'll have the graph with the numbers or you'll have to draw it? You will have the graph with the numbers. You will have something just like this. You know, it'll be blank, just like the page, and you just have to put your graph on top. You don't need to do any extra work. Like, you don't need to put in 0.5 and pi over 18 and all that. You just need to put the points on the graph. I'm not a savage. I wouldn't make anyone do that. I haven't made anyone do that since people had graphing calculators. It'd be crazy. In my opinion. In my opinion. Okay. Any questions on that? I'm assuming not. So let's just try the very next question. Same story. So if you knew what you were doing or you understood what I just did, just try to do this yourself. I'm still going to talk you through it, but you can try it yourself. I'm going to go step by step. What's the amplitude? A. A is 3. That means amplitude is 3. Right away, I can fill in my y values. This is a sine curve, so I'm allowed to use my rule. 0, 3, 0, negative 3, 0. Notice that that's a negative. What is my displacement? That's going to go here. Well, I don't know yet, so I'm not going to worry about it. I'm going to get b. What's b? 1/2. What's my period? Period, b is 1/2. Good job, Hamza. Period is 2 pi over b. In other words, 2 pi over 1/2. That gives 4 pi. We've done that one before. So that means that period divided by 4 must be pi. Let me make that more clear. Period divided by 4 is 4 pi divided by 4, which is indeed pi. Okay. I just want to make sure that no one's getting lost here. Okay, that is my distance between points. So that's what I'm going to add each time. I'm going to add pi. I'm going to add pi. I'm going to add pi every one of these times. As soon as I get displacement, I'm pretty much done the question. Just get displacement, add pi a bunch of times. So what is the displacement? Has anyone calculated it yet? It's negative c over b. Oh, what's c? Negative pi over 8. So this is interesting. Negative pi over 8 over 1 over 2. 1 over 4 pi. No. So, wait. Did I get, let me make sure got all my things correct. Yeah, okay. I want to give you a trick for doing fractions like this. You can always multiply by the reciprocal, but one way that I like to do it, which I actually only remembered earlier today when another student reminded me. When you have two fractions, there's a trick. And it is a trick. It's just a shortcut way to remember it. You multiply the far ones and multiply the close ones. What I mean is the ones that are furthest away, so negative pi and 2, multiply those. You get negative 2 pi. And multiply the close ones, 8 and 1. You get 8. Okay? This gives the top, this gives the bottom. Tippy tops, the furthest away, and the close ones. Yes, there is 2 negatives. Thank you, Ali. I did not notice. There's 2 negatives. So they'll cancel. They'll make positive. Thanks for that. And now that's pi over 4. Not quite enough space in this unit. Okay, so I want you to know that, first of all, I really appreciate it that you're sending your answers in the chat. It doesn't matter to me if they're right or wrong. That's not the point. The point is that you're trying it, you're communicating, and we can talk about it. If no one communicates, I can't tell if you're doing it well or not, and I can't give you any help. So first of all, it doesn't matter to me if you're sending wrong answers. I'm just glad that you're sending answers. That would be my first thing. The other thing is just make sure that when I do send the other answer, my answer, you can check it. I could be wrong. I'm usually not. I try not to be because I do a lot of the work ahead of time, but I want to make sure that it's clear, right? So up to this point, we have our 3 pieces, amplitude, period, and phase shift. In fact, we didn't even need to fill in this table yet if we didn't want to. We could start it now. It's up to you. But the important thing is that once you get displacement, that's what goes in your table first. Okay? Then you'll add pi. What's 1 over 4 plus pi? Well, I can make a little sketch here if I wanted. Pi over 4 plus pi. You can do it on your calculator, or you could do it by common denominators. I expect you to use your calculator, but if you did it by hand, it would be this. 5 pi over 4. If you add another pi, it will be 9 pi over 4. If you add another pi, it will be 13 pi over 4. If you add another pi, it will be 17 pi over 4. All right? So that would just be a calculator exercise. There's nothing crazy complicated about it. Make sure you know how to use your calculator no matter what type you have. You should be able to do this. Most calculators can handle fractions. So I would just normally say pi over 4. Oops. I hate this touchpad. I need to get a mouse for it. In fact, I'm just going to use this. I'm using my webcam in there. Anyway, pi over 4. I'm going to add pi. It's 5 pi over 4. If you wanted just to add pi again, you don't need to overwrite your previous point. You can just press plus. If you press plus now, it'll take the answer and you just add pi to it again. Add pi to your answer. 9 pi over 4. Add another pi. 13 pi over 4. So this is how we get these numbers, okay? So hopefully it's not too scary or overwhelming to get this. It's not as much work as it might seem. So we've got our numbers now. We've got our table full. All we need to do is put these numbers on the graph. But there's one tiny problem. And if you looked ahead, you might know what the problem is. This graph, let's, for example, look at pi over 4. This graph doesn't have pi over 4 on it. So I know, Ibrahim, I told you I wasn't going to make you draw it. I won't. On an assignment, I'm going to give you this. But in this particular question, something went weird. So if this is pi, what's pi over 4? Well, there's 1, 2, 3 pieces in here. There's 1, 2, 3, 4 spaces. So it must be pi over 4. Every jump must be pi over 4. So we divide it by 4. Pi divided by 4 is pi over 4. This is 2 pi over 4. And this is 3 pi over 4. This would actually be 4 pi over 4, but of course that would cancel. That's why it looks like pi. And we keep going like this because we need some special numbers. If you keep going with this logic, you'll get 5 pi over 4. That's one of our numbers. You'll get 9 pi over 4 here. You'll get 13 pi over 4 over here. And you'll get 17 pi over 4 over here. And those are all the numbers that we need. I'm just going back to my table earlier on the page and finding which numbers they are. If you're not sure where they're coming from, just pay close attention right now. Every single one of these jumps is pi over 4. So we have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and so on. Just keep counting up until you get the numbers that you need. But for an assignment or a test, very good chance I'm going to give this to you anyways. So we've got to do it for this question, but I'll go easy on you for an assignment or a test. Okay? You're welcome. You're welcome. You don't need to thank me. Yes, so Hamza, you're drawing the curve. Yes, of course you are. I'm just saying that the numbers themselves on the axes will be there. So if I needed you to put these on, it'll be, all the numbers will be there already. Let me just show you what I mean. Like for this question, for this example, all of the points land on these numbers that are already there. Okay, so that's what I mean. I'm going to keep it fairly simple because it's already enough work. Okay? Okay, so hopefully you have your numbers in front of you. I've got the numbers in front of me. It's okay, Hamza. Pi over 4 and 0 is our first one, right here. I'm just going to do something a little different this time. I'm just going to do the last point. So 17 pi over 4 and 0 is our 0.5. And because of the way this works, halfway between them, you can just go right in halfway. You know that it's going to look like this. And halfway between these two, you know is going to be a maximum. So it's up here. And halfway between these two, you know is going to be a minimum. It's down here. So if you want to, you can do these pretty fast. But if you need to, just go back in the table, be really careful, make sure you label things properly. So I'm going to sketch this. This is your chance to get practice sketching as well. Again, not an artist, but doing my best. Oh. Good enough. Wow. I don't know if I had too much coffee or not enough sleep or what, but that's a terrible graph, but it's good enough. It's good enough. If you do at least better than that, you're okay. Actually, I have 1 point wrong. I've got 1 point wrong here. I think someone might have looked at that, might have noticed. I mean, it is still a sketch. It doesn't need to be perfect, like you said, Hamza, but at least be presentable. The important thing, I need to be able to see what you're trying to do. And really the most important thing is that it should look like a curve. You should never have a point bigger than your maximum point or smaller than your minimum point. And you need to make sure that you're not drawing straight lines. As long as you understand, you're good. So some students, for some reason, they like to make as many points on the graph as they can. And you don't need to do that. I mean, it's just something that some students do. So they'll see, okay, that point, this point, this point, this point, this point. Where do you think the next point is going to be? You don't need to do any math to get that. You can just follow basic patterns and you'll know that the next point has to be up here. So some students actually like to just keep going Sorry, I just turned off my Surface by accident. Some students keep going and they'll just, you know, finish off the curve. Because really, sine and cosine go on forever anyways. But it's up to you. You only need to make the 5 points. That's what the question's asking. Man, my nose is itching. I'm so sorry. I shouldn't be touching my face, but it is what it is. So, despite the fact that I made a pretty ugly graph, is there anything I can review for that? I'll do one more on cosine, then we'll do the next topic. Anybody? It's pretty quiet. Pretty sad, actually. There's only 1, 2, 3, 4, 5. It's only 7 of you. You know I have 20 students in this class, right? I don't know how some students still get such great marks and they don't even come. Show me again how you got the points. Yes, of course. You mean the ones in the table or on the graph? The graph ones. Okay, so I'll erase, let me see. Okay. It all has to do with this. It really comes down to finding some points that are easy to understand. Okay, so watch this. Go from 0, and I just find a nice easy point that I'm comfortable with, which is pi, okay? I can see that pi. I just don't have any information. Like when this started, I didn't have any of that information, right? I had to figure it out myself. But I knew that pi was there, and I knew that there's 1, 2, 3. Well, really, there's sorry. There are 1, 2, 3, 4 jumps to get to pi. Or in other words, 1 jump, 2 jumps, 3 jumps, 4 jumps. So each one of them has to be pi over 4. So the first one's pi over 4. Every single other one I just figured out from that. Pi over 4 is the first one. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, blah, 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 until you fall asleep, right? So just find 2 nice, easy points, or find pi or something, just cut it up and then add it. Hopefully that's helpful. Okay, let's do one with cosine, which is almost exactly the same. The table just is shifted by 1. And I'll show you what I mean. So the next question here, be extremely careful. As soon as you look at this question, you have to see if it's asking for sine or cosine. If it's asking for sine, we do what we just did. If it's asking for cosine, we just have a tiny different method. I kind of skipped through it, but I'll jump back. You don't need to go back yourself. You can just watch. I just want to show you the difference. For cosine, notice that it starts at 1. That's the only difference. It's been shifted. And like you said, Ali, max 0, min 0, max. Exactly. All of this is exactly the same. The only difference is this, which is exactly what you said. For cosine, it's max 0, min 0, max. For sine, it was 0, max, 0, min, 0. So that's the only difference. That is the only difference. The rest of the question is exactly the same, which is why I'm only doing one example on it. Okay? So I'll just scoot forward to practice 3 here, and we'll get it done. You can use this cheat sheet if you need it. It's in your notes. Let's get it done. So 5 is A, which means amplitude is 5. Right away, I can fill in the table. I'm going to use Ali's suggestion, max 0, min 0, max. So max 0, min 0, max. I'll write it one more time so that it's burned into your brain. For cosine, max 0, min 0, max. I'm going to go ahead and get B. B is 3. I'm going to get C. C is pi over 2. If I know that b is 3, I know period. It's 2 pi over 3. I'll show it just one more time. We know period is 2 pi over b, which is 2 pi over 3. We need to divide it by 4. Period divided by 4 is 2 pi over 3 divided by 4. You can use your trick. Remember, these two numbers are multiplied. That'll give us 2 pi over 12, which is the same as pi over 6. Okay, so my period divided by 4, or my thing I'm going to add every time, is pi over 6. Okay, I'm just going to write it once. I think you get the idea. That's my period divided by 4. I just need my phase shift now. Let me just move this up a little bit for space. Displacement. Displacement is negative c over b, same as always. And again, displacement is phase shift. Negative c is negative pi over 2. B is 3. Same thing, you can just multiply the two bottom numbers, 2 and 3, that makes 6. So Ali, you got it, negative pi over 6. So just by chance, the phase shift is very similar to the period over 4. That's just a coincidence. There's no connection there between the two numbers. It's total chance. I don't think that there's some pattern there. There's not. Negative pi over 6. All right, and now we just need to add pi over 6 every time. So what's pi over 6 plus, what's negative pi over 6 plus pi over 6? You can use a calculator or you can just think about it. Well, it's a negative and a positive, must give 0. What's 0 plus pi over 6? Pi over 6. What's pi over 6 plus pi over 6? It's 2 pi over 6, which is pi over 3. What's 2 pi over 6 plus pi over 6? It's 3 pi over 6, which is pi over, wait a second. Yeah, pi over 2. And of course, you can do it on your calculator or on paper, whatever way makes you happy. I'm just doing it in my head. I don't know why, just because I feel like it, I guess. So just as a reminder, this period over 4 is what number this comes from. And yeah. All right, my little flow chart, so you can make sense of what's going on here. Okay, so I hope you'll believe me when I say these actually don't take that long. If you know how to get A, B, and C, use your formulas to get your 3 other pieces, fill in your table, and just make your graph. So that's what I'm going to do now. I'd like you to make the graph at the same time. And let's just, I can't really compare. It's not like you can send me pictures. Well, you can, but it's a pain in the butt. So just, you know, follow along and do your best. So negative pi over 6 and 5. Notice it's doing what I expected. Cosine starts at a peak and comes down. Sine starts at 0, 0. 0, 0, pi over 6 and negative 5. Pi over 3 and 0. Pi over 2 and 5. After this point, I'm just going to follow the pattern. So for those students who are looking to get every single little piece of marks they can possibly get, maybe you'd add in the extra pieces, but I'm not actually going to give you extra marks for that. It's just some students like to draw, so they do that. Feel free to do that. I'm going to try and make a curve slightly nicer than the last one I made. No promises. Now let's see here. I'm left-handed, so this is difficult for me sometimes with the surface. It's so ugly. It's good enough. Maybe I shouldn't be so hard on myself. I'm doing my best. I think that's acceptable. Okay. So Ali, sir, do the graphs give you the values of displacement? Yes. So that's something that we're going to see in the next topic. Let's be clear here. What we're doing right now, we're given the equation and we're making the graph. So we don't need to know the phase shift ahead of time. Okay. Yeah, okay. So let me be clear here, saying it would mean we know the displacement without calculating. That's true. The problem is we can't get the split. In this question, we start with only the equation. So if you only have the equation, how are you going to get the displacement unless you have the graph? Like if you put it on Desmos and get the displacement that way, but I mean, you have to calculate it if you don't use Desmos. Do you know what I'm saying? Unless I'm missing something. Is that what you're asking? For sure, when we finish this graph, we can see the displacement. You know, it's this distance. But we got the graph from this. No. Okay, I want to be crystal clear. The question on the assignment will be exactly like this question. So for example, the question on the assignment will be like, I'll give you this with a graph, a blank graph. It'll be this. It'll be the equation, a box, some space, and you do the graph. It's identical to this. Everything that's missing now will be missing on the assignment. I'm not giving you the curve. You draw the curve. I'll give you all the other pieces. So, but you made a really good point. If you had the graph, you could get the displacement. And that's exactly what we're going to do next. We're going to only have the graph, and we're going to get amplitude, period, and displacement from that. And we'll see we can get the equation pretty easily. It's actually easier than this process, in my opinion. Okay, so before I move on, are there any more questions on this? Hopefully you can see they're not as long as they might have seemed. Nope. Okay. We're in the home stretch. I just need a little stretch here, sorry. Sometimes when you teach for, you know, almost 4 hours in a row, you get a little stiff. You gotta shake it out, right? Something popped in my shoulder. That can't be good. All right. We can take a break and come back in a few minutes if you want, but I think most people would rather just get it done. So maybe let's just get it done. Do you want a 5-minute break? Does anyone actually want a 5-minute break? I didn't think so. Let's just get it finished. We're going to finish early anyway. Let's get her done. So the next section, I don't really like how it's introduced. I'm going to introduce it in a way as clear as I can without reading every single piece of text here. And again, Mr. Tom went through all this, but like I said yesterday, I'm going to be doing a lot of what Mr. Tom is doing in class, because this topic, Unit 5, Unit 6, Unit 7, especially Unit 5 actually, it's just better if I introduce it, because it's better to introduce it, do some practice, introduce it, do some practice all together with us in class instead of just watching the video. The videos are still there, but I'm going to be doing some repeat information. Anyway, so finding the equation from a graph. You'll think, you know, we just got a graph from an equation, now we're finding the equation from a graph. And for those of you that have lost track of where we are, this is page 32. So it says that the amplitude will give us the value of A. Now let's be clear here, the graphs we're talking about are the graphs of sine and cosine. And really all that means, if we are given the graph, we still need to find the same three pieces. When we're given the graph, we still need to find A, We still need to find B, and we still need to find C. I don't know why that deleted my A. Okay, so the whole point of this is really, how do we find A, B, and C from the graph? And you'll find it's actually not that difficult. B is found from the period. If we know the period, then B is this. And finally, to find the value of C, you need to find the phase shift for the displacement. That's what Ali was saying earlier. You need to look at the graph and see how it's been shifted. This is found, I'm going to use one more color here. I hate yellow, but whatever. This is found by determining where the original y-intercept has moved. I'll talk about that more later. Let me just make a quick summary. A is just that, big A. B is 2 pi divided by the period. And C is negative B times the displacement D. Okay? That actually says that there, but it's a little bit hidden. Like, some of these notes are not amazing. It is hidden down there, but I wanted to make it clear. So let me be crystal clear. I'm going to write one more note before we do the example. I'm going to say it's a good idea to get the amplitude, good idea to get amplitude, period, and displacement first. All right? If you get amplitude, period, and displacement, it's very, very easy to figure out the rest of this. So this will be a pretty short section, and we can finish early today, almost definitely. Let me show you my way of figuring this stuff out, okay? It says, determine a sine function. It's extremely important that you see that it says sine. It does not say cosine. So we're getting a sine function. That means we're going to be getting something that looks like this. If it was asking for cosine, use the cosine version. And that's it. There's no other information. So let's try and figure out what we are looking for. Well, what's the amplitude? Hopefully you can see from the graph what the amplitude is. It's a little bit tricky because it's not clear. It is not 1. The amplitude is this height. And what is this? It's not 1. Everyone says 1. It's 1.2. Yeah. Because if we look at this carefully, if you look at this carefully, take your time, you'll see that this is 0.2, 0.4, 0.6, 0.8. It's actually 1.2. Okay, so be careful. Kind of like those terrible measuring tapes in the physics lab. They go up like groups of 2 every time. I don't know why. Anyway, so A, amplitude is 1.2. A is 1.2. So we have A. In fact, I can already start writing my answer. And you'd have a mark there. That's A. Period is a little bit extra work. Does anyone know what the period is just by looking at this? Remember, the period is the distance between any 2 points of the same distance. So you're saying 2. Period is definitely not 2. And the period is actually not 2 pi either. I have a feeling maybe what you're looking at is this, and you're comparing it to here, but that doesn't really work. Let me show you why. For example, I wouldn't write this down yet. Let's just say I wrote down a point there and a point there. That is the distance from one cycle to the other, to the start of the other cycle. So the cycle here, it starts here, goes down, comes back up, it's going to start again. That's our period. So the distance is actually this, but that's not easy to figure out because, you know, what is this value? And what is this value? So I'm going to erase all that. I'm going to show you a much easier way. Most times, if you want the period, it's very simple to just go from the y-intercept. So look over here. Find that point on the curve. So let's go up, come down and find that point again. Hey, it's right there. So what we actually can find is that the period is 3 pi. Distance between those two. Okay. If you take any two similar points on the curve, you can do the same thing. So for example, from here to here, that's 4 pi minus pi, or 3 pi. So same story. If you take, let's say, here and here, that's pi over 2, and this is, what is that? 7 pi over 2, which is an awkward one. But if you subtract those, you also get 3 pi. Let's see. So there's also 2 points where it intersects the x-axis. Let's see. Yeah, okay. Yeah, these two, yeah. Any 2 points, honestly, any 2 points on the curve that match. You could take this and this, although it would be a crazy idea. There would be no reason to do that. You can't take here because you can't find that point. You'd have to go a whole cycle and it'll be down here somewhere. So obviously that wouldn't work. But long story short, to get the period, almost always take the y-intercept. Okay, take the y-intercept. Use this and get the distance between them. So let me write down what we've accomplished here. Period is 3 pi. The reason we needed the period is because we really need b. And we remember from earlier, b is just 2 pi over the period. Or p, whatever you want to call it. So b is 2 pi over 3 pi. Cancel, cancel. B is 2 over 3. We've got A and B. Oops. So sometimes I try to color code and it just takes a lot longer than it's worth. But it's worth it for some students, I'll tell you. All right, I'm already done. Almost. Because this isn't quite the function I want. Let's see, pi over 6 is c. No. Close, but no. The displacement's the hardest thing to get. So as long as we get the displacement correct, you'll probably get c correct, because we've done that before. But let me try and show you a foolproof way to get displacement, okay? It all starts with knowing what the sine function is supposed to look like. So sine is supposed to look like this. And sine is supposed to have a y-intercept. Sorry, let me move this over. Sine is supposed to intercept right here, okay? The problem is this sine, I can kind of take advantage of the technology here. This is my sine curve, yeah? It's like it used to be here. Okay, that's my sine curve. I didn't finish it, I don't know why. And it's been shifted to the right. How much has it been shifted to the right? It's been moved to the right by pi over 2, which, yeah, was already said by Ali, I think. I'm looking. Ali, I'm trying to look at the chat here. There's a lot of numbers. Yeah, pi over 2. So let me be clear as to what I said. The way to find displacement, the y-intercept for sine starts here. You need to decide how far has it shifted. In this case, whoa, it's been shifted to here. So just tell me what that distance is. And that distance is, in this case, pi over 2. So that's our answer. The displacement, not c, but the displacement, is positive pi over 2. From that, we can get C, which is indeed negative pi over 3. And you can get the answer. So if you've already got this question done, try B. I'm going to do B next anyways. If you don't have it done, you can watch. C is negative B times displacement, which is the same as getting negative C over B and working it out that way. C is negative 2 over 3 times pi over 2. The 2's will definitely cancel. That leaves us with a negative pi over 3, which is what you were saying. Why do I bother to color code this stuff? All right. Nice. Done. And I'll add it into my formula, and she shall be complete. Put a box around that. Little trophy case. We've got our answer finally. So I don't want to make it seem like a lot of work. It's really not. If you understand how to read the graph, you get amplitude, that's simple. You get period, that's almost as simple. You just look at the y-intercept and see where it goes one full cycle. Displacement's the hardest one, so notice where it's been shifted. So I'm going to just quickly check my answer on trusty old Desmos here. Get out of here. So let's see if my answer looks like this. Okay, 1.2 sine 2 over 3 x minus pi over 3. Now, does this look the same? Let's get the scaling right. That looks about right to me. Doesn't it? Doesn't that look the same? I can go up by pi. Let's check some values. What's the amplitude? Again, I'm using the equation that we just found to compare. The maximum is 1 over 1.2. That's good. The minimum point, also 1.2. The displacement, is 1/2. That's extremely important. The displacement here is pi over 2. What else do we have? We have period. Is the period 3 pi? It is. It's not as clear, but it is. And that's it. We've got it. We've got the graph. So even just by inspection, and by that I mean just by looking at the graph, you can see that it is what we're looking for. You don't need to graph it yourself, but it is a good way to check if you're not sure. It definitely looks similar. Okay, so we've built our own equation, which honestly is pretty powerful, and you can do a lot of stuff by building equations later in math courses. But for now, we'll stop it there. Let's do 2 more examples, this sine one and one cosine one, because again, on your assignment, you're either going to be asked one like this, with sine, or you'll be asked a similar one for cosine. So I want to do one more example on sine. Very straightforward stuff. We know we're looking for a sine function. So let's start picking it apart. The amplitude, what is it? Well, I can see that it's 2. So right away, I can get my A value. A is 2. That one's almost free. It's like free marks. If you can see the graph, if you can look at the graph, you can see that much. You're saying A is 2, B is 2, B is 2, C is not 0. C is not 0. Well, I'll try that one again. B, well, we need to get the period first. Period here is very easy to see. This is the period. Let me maybe make it clearer. From here to here is the period. So it's pi. Two pi over period. So b is 2. Okay, so the period is fairly easy to figure out, in my opinion. Maybe my opinion might not mean that much. It might seem like I know everything, but I really don't. That's the distance from the start of one cycle to the next cycle. And yeah, it's a sine graph, not a cosine. The trickiest part by far, and I really do mean this, is getting the displacement. What is the displacement? I'm really curious to see what you guys say. Let me just graph what it's supposed to look like. You know, a basic sine graph looks like this. So we need to say, all right, it looks like it's this now. It's almost like it was supposed to be this, you know, in the middle of the page, and someone took it and pushed it sideways by this much. Or in other words, the y-intercept used to be here, and now it's here. What is that distance? What is that distance? What's that value? Negative pi over 4. Yeah, it's half of pi over 2. So if the value is pi over 2, if this value is pi over 2, and this is half of it, well, just divide it by 2. So our displacement here is negative pi over 4. But again, I'm telling you, I'll usually have it marked on the graph just to save you a little bit of work. So the displacement is indeed negative pi over 2. Oops, negative pi over 4. C follows. So negative b times displacement. C is negative 2 times pi over 4, negative pi over 4. That means it is pi over 2. And now we're done. And Ali, you said something really interesting, which I don't know if everyone noticed, but I'll make a note of it. You're totally right. So if everyone can see in the chat, Ali said 3 pi over 4 for the displacement. And honestly, he's right. As long as the shift matches, it's going to be correct. And by matches, I mean, instead of shifting this left, maybe, you know, in Ali's example, instead of going from here, maybe the function was just shifted over here. And then we started the function. And that's totally fine. That is perfectly correct. That would be a shift of pi over 3. Sorry, totally wrong. 3 pi over 4. That's a much harder displacement to find. So I'm not going to keep it there. I'm actually going to erase that. But it is correct. So I'm still going to write it down here. You could also write 3 pi over 4. But that's a harder one to get. I'm happy that you found it, but no need to worry about that one. I'll put a little mark there just in case you want to think about that. All right, so that's done with sine. I'll do one more of cosine, and we'll be good. I just want to quickly graph this one just to confirm. Sometimes I don't trust my own work. I'm pretty sure this is right. But let's check. Let's see, 2 sine 2x plus pi over 2. Whoa, it's a crazy looking one, huh? What's going on here? Let's see, scale is 1, and we want 3 pi over 2. Stretch that out a bit. See if I can force it to look like what I want it to look like. I don't think she's gonna do it today. Oh, it's 2, yeah. Okay. Why is it following that point? Give it up. All right, that's, I think it's right. That looks right to me. And again, if you're looking at this, you should be able to say, yeah, my equation matches. I can definitely compare it. I can see it goes up and down and up and down and up. Up goes through 0, down and up and down and up. Those are the same function, 100%. So you can always check your work on Desmos if you want to. If you don't want to check your work on Desmos, no, there's no problem. I mean, I'll never know. I'm just giving you the suggestion to help you. But what you do ultimately is up to you. So you can always check your work if you choose to. Let's finish this off because I'm about to fall asleep. Not because this is boring, but because I've had a very long day. Okay, C. Actually, C is not the one I want to do. Let's skip up, keep on going. That example is done by Tom. You can try some of these for homework. Any of these are perfectly good examples that you could try for practice for the assignment. Any of them. There is more than enough practice in this book. And on D2L, there's like, I don't even know how many review sets I've got on D2L now, probably 10. There's like 4 on just this topic. So just, there's more than enough practice if you need it. Anyway, let's do this. This is a function of cosine, which means the answer needs to match the cosine form, not the sine, but everything else is the same. Let's do it. I'll do this one fairly quickly because I don't want to waste your time. What's the amplitude? The amplitude is 0.8. 0.8. Okie doke. What's the period? Can someone tell me the period very quickly? This one's easy. Should be able to get it. pi. Don't everyone say it at once. Pi? Pi? 1 pi? 12 pi. 12 pi. That's the period. It's the distance from one cycle to the start of another, yeah? Remember, it goes up, comes down, and has to start again. Some students say this and say the period is 6 pi. That is totally wrong. That is half a cycle, all right? So be careful. Let's get B. B is 2 pi over the period. B is then 2 pi over 12 pi, which it looks like you got 1 over 6, which is excellent. That's perfectly correct. Cancel the pi's. 2 over 12 simplifies to 1 over 6. So I've got B. All that's left to do is C. I'll put it into my equation and it'll be all good. My displacement, what is it? This is tricky. Don't get too cocky about this. Let's be careful. Cosine looks like this. Well, it doesn't look like that. That's a hideous cosine, but you get the idea. The y-intercept is at the top, not at 0. So it shifts. The cosine, again, let me show you this. Let me find a good way to do this. This would be what the cosine was supposed to look like in red. And it's like someone came in and was like, I don't really like where that cosine is. Can we move it, please? And we're like, yeah, sure. Where do you want to move it? And they moved it over here. Now, of course, that's just a sketch, but they've shifted it. They've moved it to the right. That intercept is supposed to be here. There was supposed to be a y-intercept at 0, 1. It's part of this definition. But instead, it's here. So all you need to do is tell me what is the size of that. And that is, if I can read this correctly, that's 3 pi. Okay, the displacement's 3 pi. That is the hardest part of this question, in my opinion. That's the one that students have the most trouble with. So just keep it in mind, cosine has a standard form. It always starts at 0, 1. It's supposed to come down. So if it doesn't start there anymore, you have to think about how it must have been shifted. And from that, we can get everything else. So negative b times displacement. C is negative 1/6 times 3 pi. The 3 and the 6 will simplify, and we end up getting negative pi over 2. That's C. Make sure that you write the final answer in terms of cosine, and you'll be fine. 0.8 cosine 1/6x, or we can say x over 6. Sometimes we see it like that, minus pi over 2. All right, and just to be consistent, I'll color code this so that no one gets lost. And that is the end. I'll stop the recording here. Thanks, everybody. Happy studying.